approach to today's class. We're going to do a very brief introduction to patterns and standards, and then we'll be going through Project 2 queries. So anybody who has questions about Project 2, we can answer those and then see how that goes. And then we'll take a brief look at Project 3 as well. So let's just quickly take a look at slides. I just want to share my slides quickly. All right, can somebody please just confirm that you can see my screen?
We can, yes, ma'am.
Brilliant, thank you very much. All right, so let's get kicked off. Welcome back. Today, like I said, we're going through patterns and standards. That's the new work that we're going to be looking at. And as soon as my screen responds, there we go. We can move over to the next slide. So just a few things from our recap of the week, or the sprint at least. You should have by now figured out that when you log into Teams, if you're logging in as an external user, you're supposed to use your name and student number. And I'm repeating this again, like we do in every class, because there are still people who don't seem to be getting that right. So I just don't want there to be any confusion at the end of the semester when the portfolio of evidence gets marked and there's attendance marks that are missing. Okay, can somebody just I'm getting some feedback. Cool, thank you. Perfect. Then with regards to Project 2, you should be polishing off your solution by now and you should be getting ready to submit. For those of you who don't know, the submission deadline is at 5 o'clock this afternoon. Don't forget to add your reference list, keep your repository private, and please note there will be no project extensions. You guys have had 4 weeks, even more actually, because the project brief was set out in the second week of getting getting to the semester. So there shouldn't be a reason why we would need extensions. The only reason you'd actually need an extension is if you left it until number 99 or if something went severely wrong. So for that reason, we're not going to be giving any project extensions or extending any project deadlines. That's the point of Project 1, making sure that you know exactly what is expected of you and that you can do what you need to do within the time frame that has been given. Now, with that being said, those of you who finished Project 2 early, I know there are quite a few of you. Hopefully you would have looked at Project 3's brief. If you haven't, it's okay. We can still do that today. We're going to start looking at what that looks like and what is entailed there in a bit. Training should be underway after today with patterns and standards, considering that your Project 2 should be in. Then what we'll be doing is we're also going to be looking at the solution that we've now started looking at creating for the portfolio of evidence submissions. So I keep telling everybody who emails me that we are still trying to decide what the best way would be to handle these updates to the portfolio of evidence. Now, the reason for this is because we've been going back and forth about what would be the best way. Do we get you to submit a Microsoft form every single time that you make an update? Do we create something that can actually help you track your progress? Do you just put it all in a Word document and we look at the Word document? Do you submit it all at the end of the semester? So these are the kinds of things that we've been thinking about. And essentially what I've started doing is actually started playing with the Power App to see if we can actually help you track what's going on and if we can pull through all your stuff and start auto-populating some of the information for you from your previous projects. So I'm hoping to be a little bit further along with that next week, and I'll actually show you what that looks like. Along with that, we're also trying to build a progress tracker so that you can see exactly what your module mark is as you go along in the semester after marks and stuff have been released. I know Ifundi is supposed to be there for that, but Ifundi doesn't necessarily take into account our calculations correctly. So we're going to see what we can do from that perspective. It is a side project for us. We're also learning and kind of embracing new technologies as we go along in the semester. So hopefully our excitement about the technologies will rub off on you as well. So that's from a recap perspective. If you have any questions, please just drop them into the chat and we'll answer them as we go. Specifically relating to the content that we're dealing with now, Project 2 queries, the actual coding queries, and I see there's quite a lot happening in the chat. We'll go through that in a bit. So if you have any queries or questions about what I'm going through on screen and the content that we're going to be covering from a theoretical perspective, please pop that into the chat. All right, then from a Project 2 perspective, we've gotten a lot of questions about the Project 2 submission form, which I'll take you through now. Then what I also just want to do is urge you to double check the rubric, make sure that you're not losing any marks, make sure that everything's published, make sure that everything is sitting in source control, that you've updated your Scrum implementation project, all of those things. Can somebody just mute themselves, please? Now, because I'm asking you really nicely to just go double check this, because if you have done something like not put your stuff into source control, you're losing something like 55% of your project. So just go check on the rubric, all those indications of the marks that you could lose if you didn't implement something is there. And make sure you pay special attention to that. We're not going to be making any exceptions by the end of the project. Then what you're going to want to do is just double check your pricing of your resources. A lot of people have already run into the issue where their subscription has expired or has been disabled because they ran out of credits. And the reason for this is because you haven't correctly priced your resources. So your app service was supposed to be on a free service plan. Your database was supposed to be on a basic tier. And if you did that, then you should only be really consuming $7.15 per month, which means that you should be able to go for almost a year with what you've got. I know the API manager has a few more costs associated to it, but essentially, if you're doing the bare minimum, you should not have run into the credit limits. So please just double check your pricing of your resources, go adjust it. It doesn't mean you have to delete everything and recreate it. Just go into your service plan, go into your database and change your tiers. If you're stuck, just pop a message down in the chat and I can show you how to do that. Once again, make sure that your repository is shared with everybody who needs access to your repository. Make sure your project is updated. And if you have, by some miracle, used somebody else's repository, please just add it into your reference document so that if you are caught with plagiarism, you kind of have a reference and we can understand what it is that you used from that repository, so on and so forth. Anything that you've used, any resources that you've used, please reference them. One of the questions that I got was, do we need proper referencing, as in academic writing referencing, or is a bibliography enough? In essence, it's up to you. I'm okay with the bibliography. If you do want to do the EndNote referencing thing, you're more than welcome to, but for me, the bibliography should be okay. I just want a kind of like an explanation of what you used from there. All right, now, let me just quickly check if there's any questions so far with regards to. Let me just go back here. I said that I would show you the form, so let's do that quick. Sorry, I'm trying to get everything on two screens to work for me. Let me just check the chat quick. Okay, good day everyone. I'd like to ask regarding the following requirements as the student included stretch tasks. What does this mean? Okay, given the stretch tasks that I'm referring to is, did you do something extra in your project that wasn't asked for? Then that also needs to be shown on your Scrum board, on the project board. Okay, then Brendan asks, ma'am, can we set up API Manager because even the developer origin costs $50 a month? It said that we should use this, but it is said that we should do that on the rubric. So Brendan, that's only for people who want extra marks. If you do set up the API Manager, you can spin it down again when we're done and you won't utilize the full $50. That is pretty much just to make sure that everything works okay and that you know how to use it. Essentially, with the projects that are coming up, you'd still be able to use your Swagger API because that is free. So yeah, you can still use the API Manager if you want. So if you're bored today and you kind of want to figure out how that works, you can do that. We shouldn't take very long marking the project. So as soon as we're done, we'll let you know and you can take the API Manager down. Keep the API, the app service, keep that on your Azure. Just take the API Manager down. Okay, Simon, can I submit again after I have made a few improvements before 5 o'clock? Yes, so you can submit as many times as you want. Just make sure that it's before 5 because the form closes at 5. Okay, then everyone says check the recording of last week, follow the guidance doc. Cool. Johan says, ma'am, I'm a little bit paranoid about getting the source control wrong. Can you just very quickly recap how to place a project in source control and not lose 55%? Or just refer to resource. Okay, so the resource I'm going to refer to is your, I think it was the first, the second recording that we did in class to explain how to get your stuff into source control, as long as we can access your files in source control. So let me show you an example. Here we go. As long as we can see your solution in source control, which looks like this, it should be okay. Hold on, I went back. So we should be able to access your resource and run it and work with it like that. So that's all cool. Okay, how you get it there, not really fast. The best way to, or not maybe the best way, an easy way to do it would be to connect it up to your Visual Studio. So there was a recording that actually showed you how to do that. You can connect it up to Visual Studio. These stay behind. These are in the gitignore file. And then you actually publish your changes from Visual Studio. That works a lot easier. project that you saw now, that's your project 3 that you're going to be working with, so I'll explain that in a bit. Don't get flustered. Okay, Madeleine asks regarding project 3 and all the following projects, should we create private or public repositories? Please create private repositories and then share the repository with the contributors listed in the documents. What we've done with this project, the POT students are going to have to share their projects with a few extra people, so specifically the students' assistants. And I'm going to show you how you get that information now. Now, I'm going to move over back to the form for the submission for this afternoon because I've gotten a lot of questions about this. So people are saying that there's only 3 text fields, and for all intents and purposes, when you look at it for the first time, I get what you're saying, but essentially as soon as you start filling things in, you'll see more things happen. So if you didn't implement authentication, you'll click no and it'll take you straight to your URL for your GitHub repository. If you click yes, it's going to ask you what kind of authentication did you apply. You'll give us the necessary details, and the reason we need these details is so that we can actually access your API. We can't test your API and give you proper marks if we can't access it. Okay, then provide the token if necessary. Then the next question is use the URL to the GitHub repository, provide the Swagger URL. And then if you didn't manage to implement Swagger, I did say that you'd actually get 0, but you just need to explain to us how we get the endpoints and how we get them working and all that kind of stuff. Then the last question that actually changes your view of the form is whether or not you implemented the API manager successfully. Now, the API manager was extra marks, so if you didn't do it, don't stress. And then what you actually need to do is update your reference or upload your reference document. And here, number 12, is where you'll see everybody that you need to add. From a POT perspective, the additional people are listed here. I can put them into the document for you. But essentially, this is now a good reminder to make sure that you've actually done these steps. So POT students, these are the student assistants that you'll be adding to your Git repository. And these are all the people that you'll be adding to your Azure subscription. These top 2 are myself and Prof. Kutsia. So if you're from Vol, please just add us 2. If you're from POT, you can add the rest of these people as well. Then you'll need to check, have you checked the guidance document of 1 September for any additional details? We have some details there that may have been missed or may not have been missed. So just check that and then just make sure that you complete the retrospective and then you can submit. So that's how you use the form. Nothing too hectic. All is fine. Okay, then we've got questions here. Ma'am, is there a way that we can add files to the getignore file through Visual Studio? No, so you have to do that manually through a notepad file or something along those lines. Marinu asks, does Vol have student assistants? Vol does have student assistants. But I'm automating a lot of the marking and I'd prefer actually moderating the stuff. It gets a little bit tedious, especially considering that we have a watch list. I still need to keep track of what's cracking and what's going on. So don't stress, I'll manage the student assistance side of things. We do have 2 student assistants who are assisting, but from a marking perspective, I'm trying to keep it as fair as possible. Okay, then we've got another question. Does using something like Application Insights in Azure or using GitHub Workflows counts as a stretch task? Azure App Insights definitely counts as a stretch task. Git Workflows as well. So if you're actually publishing your code based on a push to your repository, that's brilliant. You'd get extra marks for that. Just make sure that you've actually implemented it and not just added it as a stretch task. Cool. Then we've got Johan is asking, will it be possible to put today's recording on Dropbox before submission this afternoon to refer back to? Yep, I'm going to try my best. Kian, okay, hold on. Sorry. I surprised Ashton Ruan's comment. It wasn't meant to be, sorry. Okay, I'm just trying to find where I am now. Okay, then Kian asks, ma'am, does that mean that if the APIs work in Swagger but not on Azure, you'll still get the marks? As long as you explain to us how to test it, you can still get your marks. If we can't test it, then obviously that's a little bit of a different story. Ruan, when I update my database in PM, I keep getting loads of errors, even when -context. Okay, you're talking about NuGet Package Manager. I keep getting loads of errors even when I use -context. Okay, so we found this out last night. There was another student that we were assisting. If you're getting stuck with creating another project or actually applying the migration from the project, create another project, apply the migration to the database, and then just refer back. Because all that you need to do with the migration is get your identity tables on the database. When it's on the database, you can actually use it, then you don't need the migration. So create a project, do the migration, go back into your main project and actually use those tables. Okay, then we've got a question here. For Vol on Azure, we add Ms. Miller and Prof only. Yes. Okay, Kaio says, ma'am, should we have dummy darts in our tables or are you looking for status codes? I'm not too sure what that means. We're going to be adding data through to your database. So we'll add a record, then we'll try to get the same record, we'll update the record, try to delete the record. That's going to be how we mark. And then obviously the status codes will be quite important there. So that's going to be how we mark. If you do have extra stuff, that's fine. SM asks, do we also add auto reboot to the repository? Yes, please. Okay, that's in the document though, which is why I haven't listed it on the form. Then we've got TT asking, ma'am, the methods that we are supposed to create, do we create them in the controller classes? I think it's a bit late to be asking that question considering you're submitting at 5 o'clock this afternoon. I'm really hoping that you have implemented them because the answer to that is yes. So if you haven't done that yet, I think you've got quite a bit of work ahead of you for this afternoon. Then as I ask, ma'am, is there a way that I can maybe drop the already created object so that the update database could work? I mean, you can try, but it's going to create a lot more work for you because then you have to go delete the DB context. You've got to go apply the migration and then add the DB context back. So you can do that. It's going to take some effort. Then Caroline says, in Azure, I see my endpoint, but it gives me internal server error 500 when I try to use it. I did add the IP addresses. What am I doing wrong? I don't know what you're doing wrong. So 500 errors are notoriously difficult to try debug. We'll have to look at that in a bit. So remember, any project 2 related code questions we'll deal with at the end of the session. So we can still get through the work that we need to go through for project 3 so that you can start looking at that. And then I'll try to help you debug that 500 because the 500 is literally internal server error. Now that could be for a number of reasons. It could be that it can't connect to your database. It could be a network issue. It could be that your routes aren't working. It could be an API manager issue. So there's so many different things and we actually need to debug what's cracking where. Okay, then Mazo is asking what do you suggest as a shorter way? So my shorter way would actually be to create the separate project that actually does the migration, creates the tables on the database, and then just go back to your original project and keep working there without needing to do the migration. If you follow what Prof. Kutsia did with a separate project, it will work. Marnu asks, ma'am, are we allowed to submit the generated methods for our endpoint? I'm not too sure what you mean there, Marnu, so you're going to have to maybe elaborate on that a bit. Okay, but while you guys are busy with that, I am going to go ahead so long with today's work so we can get to breaking this up a little bit more. Okay, so Prof. Kutsia has also said look at the other settings in the guidance doc to change. So that's also a pretty good point that Prof. Kutsia has made as well that could definitely help you. The guidance docs are really important. So if you get stuck and you can't find your answer in the guidance doc, you can't find your answer in the recordings, and you can't find your answer on Google, then reach out to us and we can assist. Okay, so today we're going to be talking about architectural patterns and design patterns and principles and all these things that generally scare people who are starting out with development. And the reason for this is because certain things are done for certain reasons and they're done in certain ways because of experience that has been gained, lessons that have been learned. As you go along with new projects, you generally get more experience. No two projects are exactly the same. There's always going to be new errors that you encounter. There's always going to be new challenges. And as you go along, you actually need to start looking at where things are going wrong and how you can change that for the future. So that's how a lot of this is actually coming into being and how people have now started formalizing these kinds of approaches that they take to putting together a solution. So this is what we refer to as the selection process. And you'll see here at the bottom, there's a blog link that I've posted. So I'm not just pulling this out of thin air. This is something that has been used for very, very long, almost 8 centuries, but I don't know if that's factually correct. So it's been used for very long. So in essence, this is something that as a solution architect, you are pretty much bound to do. This is part of your job. It's something that you have to know. It's something that you have to do really well. And there are a lot of technologies that have these kind of standards and guidelines already created. So things like .NET, .NET Core, C# Dev, Django Dev, which is then Python, Web App Dev, Java, Spring, those kinds of things, PHP, Laravel. They've already got very sophisticated design patterns and architectural patterns put together and put forward in templates that you can reuse. So if you're looking at new technologies, like you'll see with UiPath, you don't necessarily see these kinds of things coming through. And that's why I've linked you to this one over here, because the fourth project is going to be looking at UiPath, and then you can actually see how all of this starts to come together. So this is a blog post that I wrote for UiPath, and you'll see as time goes on how this actually becomes really, really useful in what we're trying to do. So like I said, I'm not pulling this out of thin air. This is stuff that we've been using and that we're trying to adopt to new technologies. And it's a really good example of how, the foundation and the theory of what you're learning in your degree can actually be used further on and later on in your career. So let's start off from the beginning. What are we trying to figure out with the selection process? What does it look like? What is it? The selection process is essentially the way that you're going to formulate and approach your designs. So if you look at the process, essentially, you would be wanting to figure out what it is that you want. What are you trying to do? How are you going to implement the solution, and what problems are you trying to solve? How are you trying to solve them? So if you look at a principle level, which is the first starting point of where you're trying to figure out what you want, this is where you're going to be looking at your architectural style. And I'll break this up a little bit further so you can understand what I'm trying to say with regards to architectural style. Now, essentially, this can be something really high level, like figuring out, do you need everything to be reusable? Do you need everything to be centralized? Do you need everything to be decentralized? Do you need to reuse a lot of your code? Is data the center of your code, or are your functions the center of your code? Once you've figured out what that style should look like, you can actually put a pattern towards it. And that's now how you're going to implement this. So principle level is essentially, as you're now thinking about this project, you've now gotten your requirements, or you're busy getting your requirements, and you're trying to figure out what the underlying important concept or element is that this entire solution should revolve around. Then at a design level, you'll start implementing an architecture pattern, and you've already actually started touching architectural patterns, and I'll show you why now. So as soon as we start bringing back some of the stuff you've done from the API perspective, you'll actually see that this becomes a lot more easier to understand because you have actually worked with this. Now, the architectural pattern is how you take what you've now decided on from the architectural style, and you place that into a design. And that becomes your high-level pattern of how you're going to lay out your code. So for example, if you're taking a data-centric approach, your architectural pattern should be protecting your data. If your data is going to change, then you need layers above that won't necessarily need to change with the solution as your underlying data changes. If your code is the essence and the kind of central point of your solution, then what you're going to be doing is you're going to be creating an architectural pattern that works around that and takes into account other things. And this is why domain-driven design, test-driven design, and those kinds of things are really important. So if you look at test-driven development, that's now the kind of approach where you take your code units and you actually build code to test your code units. So you're pretty much writing your tests first. And when you write your tests first, you're writing them to fail. And the thinking behind them is if you write your code to fail and you are now solving for all the errors that come out of that those failures, essentially the theory is that you should never actually run into other failures because you haven't coded for those failures. So if you code for all the different failures that you could get, your system or your solution is robust. But now if you have a really small application, test-driven development is actually worth more or takes more effort than it's worth. So this is now the kinds of things that you need to think about when you're selecting an architectural style and architectural pattern. Now, if you look at something like domain-driven design, that is now where you've got your object-oriented programming, and each different domain logic or kind of business function, if you can put it that way, lives in a different domain. So we'll get to that in a bit, but essentially these are the different kinds of sort of considerations that go into these kinds of selections. Now that kind of stems off onto your development level as well. So TDD can actually be more of a development principle than it really is an architectural pattern. It really does depend on how you apply it. But in essence, from a development level now, you've designed everything according to the architectural pattern. You know how everything should be broken up. You've seen your tiers. But now how are you going to implement that into something that's actually really useful? Now, essentially, what you're going to now start doing is you're going to look at your design principles. You're going to start looking at your patterns, and you're going to implement it from there. Just give me a second quickly, please. Apologies for that. It seems there's somebody at my gate. So let's continue. So from a design pattern principle or principle perspective, this is now how we start identifying how we solve for the problem that we're trying to achieve with the architectural pattern we've selected. Now, if we had to take a look at what some of these examples would look like, we'd actually see that there's a bunch of stuff that can actually come into play here. So like I've now said, from a architecture perspective, we can look at things like object-oriented or data-centered approaches, which then would lead to something like a three-tier architecture. And a three-tier architecture is where you break up your data, your logic, and your presentation into three separate layers. You can also have a two-tier architecture where you break up your data and your business controls or your business logic into two separate tiers. And then the third one is now your design patterns, and we'll get to that in a bit. So I've put repository pattern down because that's something you're going to be working with in the next project, but that's just one of many, many examples. Now that's the high level overview. Let's look at the actual very broken down elements of this. Now, when we're looking at an architectural style, that's defined by the configuration of architectural elements. Now, what does that actually mean? I mean, it's nice words put together in a sentence. But essentially what we're trying to do here is we're trying to look at or understand what components make up a solution, what connectors should be used in that solution, and what data should be used. So essentially your connectors would be things like your databases, your APIs, any microservices that you've written, any libraries or packages that you've written. And, the components are then, what makes up that code. What methods have you used? Are you using one huge solution? Are you using multiple different solutions? Are you reusing code, reusing solutions? Kind of that perspective. And then once you've decided, what needs to go into all of those different blocks or those different boxes, you can actually figure out what takes the highest priority. And that's now where you start figuring out what lies at the center of your solution. And when you figured out what lies at the center of your solution, you actually get this part here at the bottom, which is your architectural and development style. Apologies for that. It seems technical difficulties are not on my side today. I'm just going to reshare my screen. Can everybody still hear me?
Yes, ma'am.
Awesome. My apologies. Okay, let me just quickly get back up here. Can you see my screen?
Yes, ma'am.
Awesome. Thank you very much. Cool. So like I was saying, this now forms your architectural and development style, and then you start going over to the architectural pattern. So this is now where we start looking at a templatized approach to architecting or designing a solution. Now, essentially, when you architect a solution, design a solution, it does form within the same realm because essentially the whole crux of this is you're trying to figure out the plan for your solutions. How are you going to develop it? And this is now where we start looking at the architectural style and how that's going to depict what your architectural pattern should be and how it can be reused. Now, we spoke about a three-tier architecture. This one's a little bit more. This is actually a different kind of architectural pattern. But essentially what has happened here is we've broken up our core elements into different tiers. So we start off with our data layer. We then go to the persistence layer, which maintains our connection to our data. We've got the business layer, which handles any logic. We've got the application layer, which handles all integration. And then the presentation layer, which actually shows our user what is going on in the system. So those are the different, or that's an example of how you can actually implement this tier-phased approach. You get a lot more simplified versions of these kinds of patterns. So MVC is one, 3-tier architecture, 2-tier architecture. There's a whole bunch of them that you can look at. Now, the reason I mentioned MVC is because this is going to be something that you're going to be working on in Project 3. And the reason why we've kind of pre-selected what you're going to be implementing is, number one, so that we can help you understand what is happening. There's a lot of references for MVC or resources that you can use for MVC and repository pattern when you're executing on your Project 3. If you do choose to use something else, you could get stuck, or you could maybe not even implement it correctly. So that's the reason why we've predefined these, but we can always have the discussion about whether or not it'd be useful to actually try and use others as well. Now, from this perspective, we'd be looking at the MVC pattern, which in this case is broken up into 3 core concepts or 3 core elements, which is the model, the view, and the controller. Now, you should already be familiar with models and controllers, because the models are what you used in the API and the controllers are what you use to actually handle your routing, and nothing really changes there. The only difference here is we've got the view that comes in, and the view is essentially the front end that your user will interact with. Now, essentially, like I mentioned, this is an architectural pattern that breaks things up into model, views, and controllers. So it's 3 distinct components, and that's now how you get your tiered architecture. Now, this very much replicates what you would find in the 3-tier architecture, where you've broken down your data, your business logic, and your presentation, but it's not exactly the same thing. Now, you'll find that a lot of people, and in previous years, we'd let the students actually decide which architectural and design patterns they use, and then they think that they're more clever than us, and they'd say, cool, they're using MVC. It's a design pattern and an architectural pattern, and that's not true. As you can see in the selection process, you either use MVC as an architectural pattern or a design pattern. You can't use them as both. And the reason for that is because even though you've segregated your code into 3 distinct pieces, how are you going to actually implement the tiered approach? So how are you going to make sure that your data stays separate from your views and your controllers? Now, this is where you add an extra level of obfuscation, where the data actually now starts to live here next to the controller, not inside of the controller, but next to. And we'll start looking at how that works in a bit. So if we look at MVC in more detail, you already know the model is a representation of the data that you've got. The controller is now your intermediary between the model and the view. That's now where all of your user actions are mapped. And then the view is now the interaction elements that actually live within your front end. Now, the model is a C# model of a table. So if you had a table that was named user and you had the ID, the name, the surname, and the birth date, this is what your model would be represented or be representing. And you should already know the syntax of this, because this is now similar to what you had to create in Project 2. So if that scares you a little bit because you haven't done it in Project 2, then I think you've got a long day ahead of you before 5 o'clock this afternoon. Now, from a view perspective, when we're working with MVC and we're using ASP.NET Core or just normal .NET 5 or 6, you'll be using Razor pages if you decide to go with the stock standard ASP.NET framework. If you went with Blazor, you'd still be using Razor pages, but they would be referred to as Blazor pages. So it works a little bit differently, but essentially you'd actually have your Razor or your Blazor or your C# embedded into your views, which is then into the HTML. So you can actually embed functionality and integration into your views. It's not necessarily something you should do, because remember, front-end view, everybody has access to. If you inspect elements on a website, you can see a lot of things, and that's actually something that I'd exposed when I was marking your GitHub project. So the automation that I had actually used the front end to pull all the information that I needed, because the API wasn't available yet. So that was actually, this is a bit of a security flaw if you put all of your stuff on the front end. And it's not a great security flaw to have, because if people get access to all the wrong information without being authenticated, you can totally see how that's an issue. Now, on top of that, I think last semester, some of the Vol students and I had a very interesting conversation about how you'd use different elements and different styles and languages together. One of the questions I had is whether you could use different languages together, like HTML, CSS, and JavaScript. Now, in essence, that is something that happens quite commonly, but I wouldn't say that you're using languages together. you're using different technologies together. So HTML is a markup language. It's not a programming language. CSS is a styling sheet, and JavaScript, that can be classified as a programming language. So in essence, this is now how you start bringing things together. If you didn't want to create Razor pages and you still wanted to create views, you could probably use something like Vue.js. It works better with the back end of React and just pure JavaScript. So you really do need to know what you're trying to do with what technologies. MVC is something that can be adopted between multiple different technology stacks. So you don't just use it with .NET and .NET Core. You can use it with Spring, Spring Boot, all those kinds of things as well. There's even something quite similar in Django, which is the Python framework, where they call it MVT. It stands for Model View and Template. I think it's template. It works a little bit different to the way that you have model, view, and controller. The principle stays the same, but a view isn't what a normal view would be, and a model isn't what a normal model would be. It's a little bit more complex, or not complex. It's different. I actually think Django is a little bit easier to learn than .NET Core and those kinds of things. So that's the perspective of a view. This is something that should be new to you. Now I'm going to jump forward quickly, and then we're going to jump back. So the controller is now what you should already be used to. You created your get, your put, your post, and your delete methods. Now essentially that's going to change a little bit. You're going to have different methods now, which would be an index, a read, a create, a write. Well, it'll be index, create, write, edit, and delete. And in some cases you might have two. This read over here is details, sorry. You might have two methods within one controller, and we'll get to that in a bit, with the same name. So you'd have two create methods and two edit methods. And the reason for this is because when you have two create methods or two edit methods, you actually have to render what you want to display on the view, on the front end, what the user is seeing. So you'll have a create get method and a create post method, and you'll have an edit get method and an edit post method. Because think about it, when you're trying to edit an element, you already need to know which element you're trying to edit. So you actually need to go into your data source, get the element, and then return the information of the current element to the front end. That's why you do a get. So you get all the information from the front end, you put that onto the front, or sorry, you get the information from the back end, put that onto the front end. The user edits stuff, and then that has to get submitted back to the database, and that's why you've got the post. So we'll break that up into more detail next week. I'll actually take you through a demo and show you how all of this is working, but I want you to become comfortable with these concepts, because this is going to be something that's going to be really important for you to understand if you want to implement design patterns and architectural patterns in this project, project 3, that is. Now you'll see here we've got index, we've got create, we've got edit, delete, and this one over here is actually generally details. The read, write used to be custom API actions, and then you'd have custom over here as well. Now, if we come back here, you'd actually see that your views are named exactly the same. So you'll have a folder inside of your project. You'll have the views underneath each of these, and they would relate to the exact name of the controller method. And the reason for this is because there's a cool little fancy gadget in the back of ASP.NET Core and Core normal.NET that actually maps the controller to the view through its name, and then knows exactly which view to render, and it is actually quite cool. So we're going to break that up next week, and I'm going to explain to you from a technological aspect how all of this fits together. But this is MVC in a very high level. But now, what does that actually mean? Why should you care that MVC is a thing, and how do you actually implement this? So if you start off with your data, which is then living as a representation in your model, you can have one model. You can have many controllers linked to that one model, and you can have many views linked to that one model. So essentially, you can have multiple different views that represent one model, and these different views would be your create, your delete, your details, your index, all that. And then you'd have your many controller methods within, which would then link to your views as well. Now, that is an architectural pattern. If you want to use it as a design pattern, then you need to choose a different architectural pattern. So let's say now we select that as the architectural pattern, because that's going to be what you're working with project 3. Now let's look at a design pattern. Now this is essentially now where you start looking at standardized solutions to problems that you've now faced over time, and where developers have actually now started using their experience to kind of jack up and enhance the software development, planning, and designing process. Now, you get multiple different types or categories of patterns. You get creational patterns, structural patterns, behavioral patterns, and then there's this nice thing for Java where we look at J2EE. Not something that we use very often. The top 3 are actually something, 3 very common design pattern categories. And essentially, they've evolved over a very long period of time. Like I've said, as different technologies have evolved, as new functionality has come out, and as enhancements have happened, developers have learned new ways of approaching these kind of solutions and have faced huge problems that they've now brought into these kinds of patterns. Now, just to give you some perspective, you can start off with a really small application. So let's take the API that you've now just built, and let's take this web front end that you're going to be building or enhancing for the third project. Those are two small pieces of what could actually be a much larger project. Because if you think about it, this semester, and I don't know if we've communicated this clearly enough to you, but the context of this semester is actually formed around one central problem or one central concept. And that concept is the connected office IoT device management concept, essentially, or topic. Now, essentially, if you're thinking about it, IoT, the Internet of Things, is a good way to start connecting everything together. So if you're looking at a connected office scenario, you'd be looking at having cameras and motion sensor doors and cool IoT things that come together in one environment. But with that, there's a few things that need to happen. You need to be able to manage the devices that you're onboarding into your office. You want to see their statuses. You want to start testing that your front end actually works. You want to create integration points, because if you're going into security systems and those kinds of things, you actually need to integrate what you've got with different systems as well. Now, the reason I'm giving you this background is because you can see that slowly this can actually start scaling into a gigantic implementation. Because now, if you think about it, you've got one office park. Let's take the campus, right? So let's take Vol campus or Potch campus, one of the two campuses. And this kind of implementation was structured and built for one campus. But now the campuses have aligned, so now everybody needs to get the same solution. So we've got to roll it out to Mafikeng, we've got to roll it out to Van der Bijl. Let's say there's like 3 or 4 other campuses that pop up around the country. They also need to get it. Now, it's not as easy as just popping down a new solution and kind of putting it onto a new Azure subscription. You actually need to bring all of that into one environment, and that's where the scalability becomes really important. So as you start dealing with these problems where you start seeing, okay, but this solution can't scale because we didn't design it correctly, those are the kinds of learnings that you take and put back into your selection process, so that that the next time you have a problem that's going to scale or a solution that's going to scale, you've kind of thought about everything that needs to go into this. Now, there are multiple different types of design patterns. Okay, now, as I've said, there's 3 main categories, and you can see there's a bunch of different patterns that exist within each of those categories. Now, I've already mentioned the repository pattern, and the repository pattern doesn't exist here as a formalized pattern. And the reason for that is because it's actually a specialization of the facade pattern, and I think I'm pronouncing that correctly. Now, essentially what the repository pattern does is it breaks things out a little bit further. And before we get to the repository pattern, if you're feeling like Woody, where there's just design patterns everywhere, it's okay. We're going to break it down and we're going to make it a little bit simpler. Now, let's take a problem where we've got our views, we've got our controllers, and we've got our views, our controllers, and our models over here. Now, all the stuff in between is now stuff that should not really scare you as much, because you've got a table in a database, you created that for the API, you've got your database, that's existing on Azure because you're going to be submitting that at 5 o'clock this afternoon. There's a DB context that communicates to your database, but until now, it was the DB context that was communicated with directly from the controller. So these 2 folders over here didn't exist. The controller called the DB context went through all of this, the model represented the table, and all was good, all was dandy. But things have changed a little bit now in this pattern, where you actually bring in your domain logic and you bring in your repository. Now, what happens is in your repository, you actually have a bunch of database calls. So in your controller, you would have had the create, you would have had the edit, you would have had the delete, the update, all that. Those controls now move out to your repository. Then what happens is there's a domain logic class that calls everything that's happening in your repository and actually manipulates your data. Once your data has been manipulated, that manipulated data then gets sent through to the controller. And the reason for this is actually quite simple. What happens if your database changes and you're no longer using a table in a database, but you're actually using a JSON file, or you're using a NoSQL database? Nothing much changes here. The only thing that really changes is your repository is now going to reference a different class or different data source. So instead of having connected to the DB context, it now represents the JSON. Now it just literally connects to your JSON source, pulls everything through, and the rest of this all stays the same. If you didn't have these two classes and your data structure changed in the middle of project 2 and you now had to start using JSON files, you would have had to recreate this entire project because nothing would have worked. Now you can see why that's an issue. If you've got a project that is now working across 3 to 10 campuses or offices or anything like that, you've actually now got to start thinking about how do you make this robust so that you don't have to recreate a solution every time something changes. And that's why design patterns are important and why repository pattern is actually so useful. Because even if your repository changes, your domain logic will stay the same, your controller will stay the same. You can actually replicate this quite nicely. So that's the perspective of the repository pattern and why we're going to be using it. Now, I'm going to pause here quickly and go to the Teams chat because I think it was blowing up a little bit. So let's just check what's happening here. Okay, wow, there's a lot. I'm just trying to see where we last stopped. Okay, are we allowed to submit the code that was generated for our controllers if we followed our guidance dogs? Should we start everything? Okay, Marvin, let's chat about that after this. John, just trying to see your picture. Yep. Okay, for the server. Okay, so these seem to be project 2 related questions. Yeah, sorry, my connection died for a bit, but I'm back. Okay, Given says also I'd like to ask you okay, so guys, these are project 2 related questions. Are there any questions related to what I've been kind of talking about here? Yeah, Morne?
Sorry, ma'am. The selection process, is it a sequential process, meaning that if you chose on a architectural style or pattern, you can't change it again, so you have to go forward with it? Or is it like basically what I'm saying is like the waterfall methodology, it's a sequential process compared to Scrum. So can you go back and change everything, or if you chose on something, you must go ahead with it?
Okay, so that's an interesting concept. So let's think about how you'd implement this in a waterfall versus an agile methodology. So if you were to look at waterfall, you'd have your requirements gathering, you'd have your solution design, and then you'd have all of the stuff, the development and all that stuff that then follows on. So you've got to finish your requirements gathering first. That gets signed off. Then it gets sent through to the design phase. The solution gets designed, and most of this will then be selected. So up until here, this will be the design, and this will be selected as part of the design. So sometimes this forms part of the detailed design if your solution architect actually does a detailed design. They don't do a detailed design, they only do a high-level design, and this happens. In the waterfall methodology, traditionally, this should have been indicated as well. In Agile, they generally tend to leave this off. But essentially what would happen is once this is signed off and you go into your development phase, you either try it or die trying to get this implemented, or you have to create another phase in the waterfall project where you actually redesign your solution. So then what happens is you actually need to stop your development and go back. And the reason for this is because if you make a fundamental mistake in your architectural pattern, there's a lot that can be undone, but an architectural pattern is really difficult to undo without starting over. It also depends on what you're trying to achieve and what the impact would be. So if you originally went with a 3-tier architecture and you now want to change it to a 2-tier architecture because you've now figured out you don't need a web app, you only need an API, that's going to put a spanner in the work for the whole project, not just for the design and implementation, because that changes costing as well. Now, from a design perspective, from a developer perspective, because that's all that the developer really cares about, is how do I take the 2-tier architecture and make it a 3-tier architecture or vice versa? That would be quite easy to come back and change, but that's not something that you change while you're developing. That's something that you need to go back and redesign. And the reason for this is there's a video that I shared on LinkedIn, and I think a few of you have already seen it, where if you're trying to change things at development level, you actually really butcher the whole solution. And that's where Agile has become really important in our environment, because Agile allows you to go back and make these kinds of decisions without having major impact and having to restart the project and those kinds of things. So it's not, that's why solution architects are supposed to have years of experience before they can put something like this together, and why generally if you're a solution architect, it takes about 10 years to get there, 10 to 15 years to get there, unless you're working on new technologies where those kinds of skills don't necessarily exist just yet. But in essence, the reason that you need that much skill and experience is because you should know by now what should work or what wouldn't work. And if you don't know, then you need to consult somebody who does. That's why generally, typically, developers wouldn't be given a huge implementation that they need to design for.
Thank you, ma'am.
Awesome. You're welcome. Any other questions? Okay, there's a few here. Okay, there's just one. So if you have multiple pieces of software that are interconnected, do they both need to use the same design patterns? No, not necessarily. So it really depends on what you're trying to develop. Generally, what would happen is your design pattern, you could have multiple different design patterns that lead into one architectural pattern. So for example, you could have one thing that goes with test-driven development that works really well, and another one that goes with domain-driven design. That would be pretty much in one solution. So if you think about it from a Visual Studio's perspective, let me actually show you. You could have one solution over here, and you can have 2 or 3 different projects. So you can have your web app, you can have a web API, you can have a Power BI report. There's a whole bunch of stuff that you can have living underneath one solution. Now, your solution will be governed by an architectural pattern, and each of your projects might not necessarily be governed by the same design pattern. And that's where the difference comes in. It really does depend on what you're trying to achieve. Some organizations would opt to keep everything kind of consistent and make sure that the same architectural and design patterns are applied, and there's nothing wrong with that. But that's why you'd need a solution architect to make that decision to figure out what is needed when. Okay, then we've got another question here. Out of the 5 projects, how many of them will count towards participation? Okay, so I think you need to go check the introduction slides, because the answer is in the introduction slides. Okay, so are there any other questions about how this fits together? Okay, I'm sorry. Am I back? Can everybody hear me?
Yes, ma'am.
Awesome. Okay, where did I stop? Where did you lose me? Where did I lose you?
I think ma'am was on the slide with the single controller icon on, and then ma'am wanted to say something.
Okay, cool. Okay, let's try this again. So from a design principle perspective, essentially there are multiple different designs and principles that you'd want to look at. There's a nice link that I've now put down here that explain 10 of the most common developing principles. And essentially they kind of all relate to something similar, which is solid. And we'll talk about solid in a bit. So some of them that I'd like to point out is keep it simple, Simon. Other versions of this is keep it sweet and simple. There's a few of this. So don't overcook a solution. If you don't need test-driven development, don't implement test-driven development. testing is important, but you can write unit tests. You don't necessarily need to do test-driven development. Measure twice, cut once. So think about your problem twice before you develop your solution and figure out that it's not actually what it's supposed to do. Verify and validate your requirements and make sure that they all add up. Don't repeat yourself is a big one. That's code reusability. Make sure that if you're writing code out twice, you've put it into a class and that you can actually or into a model or an object and you can actually reference that. Then there's the Occam's razor, which is actually an interesting one. They refer to that as the fewest assumptions principle. So if you're faced with a bunch of different hypotheses and essentially a different bunch of ways of solving the same problem, you're going to want to go with what has the least assumptions that you're making about a solution. So for example, if you're going with a 3-tier or a data-centered approach, your assumption that you're making off the bat is that your data structure won't change and your data set won't change. You will always have the same data source. Your company isn't miraculously now going to make a massive move from one system to another, and that's not the way that life works. A lot of huge consulting firms, the one that I work for included, actually make a lot of money off of big organizations deciding that they were going to jump onto a different technology. And that's a huge implementation. It's where all of their core business for a really big organization moves over to a different system. So those are the kinds of assumptions that you need to consider when you're putting your solutions in place. Then the other one is the least astonishment principle, which means just make sure that your design isn't going to leave any surprises and have any skeletons pop out of the closet. And then those are they have more of a science behind them. But the one that I generally try to abide the most to is solid, because if you abide to solid, then pretty much all the other principles are catered for. Now, solid can be broken down as follows. You've got the S, which stands for single responsibility, which means that a class should actually only ever be responsible for one thing. You shouldn't have a class that does 10,000 things in it, because that's if something breaks, it's really difficult to see what's happening. And it's also really difficult to make your code reusable if your code doesn't just conform to one responsibility. Then you've got an open-close principle, which just means that the software module essentially should be open for extension, but should be closed for modification. So you should not be able to modify it, because once it's been developed for a specific purpose, it's being developed for that one specific purpose, because it's got one responsibility. But it should be extensible, so you should be able to use it in different parts of the code. That's what that means. Then you've got the Liskov substitution principle, which means that objects should be replaceable in the instances of their subtypes should be correct. Now, essentially what happens here is we use inheritance and we use, pretty much interface classes to implement that. And that also links onto interface segregation principle, which means that clients should not be forced or depend on interfaces that they do not use. Now, essentially what this means, and for those of you who might have some, don't know how to say it nicely, but for those of you who did Java and did polymorphism, you'd remember that you had interfaces and you had abstract classes. So your interface classes would be, kind of the pretty much definition of what your class should do. Your abstract class would also be the definition, and then your the normal classes that you have would actually provide functionality to what you're trying to achieve. Now, in essence, that is now where you start looking at these kind of interface segregation principles, where you shouldn't be referencing more than what you actually need. So when you were looking at polymorphism, you had a very small subset of what should be inherited into your next few classes, into your subclasses, and that would then essentially depict what your functionality should look like. So you wouldn't actually inherit more information and update more information than you needed in your subclass. Then you've got dependency inversion principle, which means that the program should not essentially, it should have an interface that doesn't directly link to implementation. And we'll understand more about what this actually means in the next class when I break this up into practical definitions. And you'll see that when we're going through the class, there are going to be some of these that we don't necessarily adhere to. And the reason for that is because when you're looking at this for the first time, it's really difficult to say to a student in the third year, listen, this is a solid principle, like you're going to apply this to the T. Some of the stuff takes a lot of code review. It takes some months of practice and experience to figure out what you did wrong, why you did it wrong. So we're going to start off at a foundation. We're going to make sure that you understand what you need to know and that you know the basics to get this done. And then what we'll do is classes after that will actually explain to you how you'd further unpack that and break that down. Okay, now before we go to project 3, I just want to check. Okay, we've got a new question here. Ma'am, what is the difference between MVC and business logic layer? So When you look at MVC, so the business logic layer is actually only one layer. It's not necessarily a pattern unless you're actually making it part of a pattern, then yeah. So MVC is the model view and the controller. Those are the three distinct elements that you're looking at. So you've got your representation. Your model is a representation or a set of representation classes. Your controller is a set of controller classes that have different groups, and your views are a set of essentially, as it says, view classes. When you're looking at business logic layer, that's one layer in another three set piece. Now, your business layer doesn't necessarily have a set structure of what your business layers should look like. So you know that all your models are going to follow the same format. All of your controllers are going to follow the same format. They're going to have most of the same classes in them, or the same methods, not classes. And then your views are going to have pretty much the same setup, the same implementation, all that jazz. Now, with the business logic layer, it might not necessarily look that way. You might have a business logic layer class that looks very different to another. They'd have methods, but the methods won't necessarily be the same. That's very much open to interpretation. Your data layer might not have more than one class in it. It might actually just contain your data source and how you connect to your data source. And then the presentation layer would probably be similar to the views, where you should have very consistent outlooks on how things are implemented. So there are two very different architectural patterns if you're talking about the three-tier architecture, not necessarily the business layer, logic layer specifically. The business logic layer essentially would be something that lives next to the controller, because you'd need to extend your controller into the business logic. And that's generally why you would need to apply a design pattern as well as an architectural pattern, because as you can see, the MVC pattern doesn't necessarily cater for the business logic coming in as well. If you're looking at pure MVC, business logic actually lives inside of your controller. And if your business logic lives inside of your controller and something changes on your data source, you're redeveloping almost your entire solution. Okay, so that's I think I've said a lot there, but I'm hoping you understand what I mean there. If you don't, then please just pop a message down here at the bottom. Okay, and then could I please re-explain what is meant by objects should be replaced with subtypes with regards to the Liscombe substitution principle? So that will make a lot more sense when we go through the practical and when I actually explain to you how these are broken up. So I'm going to go through that next week. If you want to understand more, you're more than welcome to go through YouTube videos and those kinds of things. But I think I can explain it until I'm blue in the face. It's going to make a lot more sense when I actually show you how to implement it. Okay, so are there any other questions before we move over to the third project? Okay, doesn't seem like it. So, okay. Now, the third project, there's a brief that's been put together. This is probably going to change just a little bit. There's a few things that I want to tweak in light of the situation we have with students whose subscriptions have also been disabled. There's a few things that we're considering with regards to the database and so on and so forth. So a lot of this might end up changing. But the first thing that you want to do is you're going to want to go into this Git repository. It's the same Git repository that you pulled the SQL script from. And you're going to want to clone that script or that repo, and you're going to see what that looks like now. So inside of this repo, I've populated or put in this connected office project. I'm still working on making it pretty and making it more functional and making it better. So if there are changes to this, please don't shoot me. There are going to be changes. There's a few things that I still want to add and make a little bit better. I can actually show you more or less what a baseline MVC web app looks like. So if we have the solution that looks like this, you've got your controllers, you've got your models, you've got your view, you've got your data, and those kinds of things. So what I'm going to show you now, just as a quick reference point, is very basically what the web app looks like that you're going to be working on. So zones, categories, devices, those connect to the Azure database that I've set up. There's some stuff that I still need to pull in, but essentially this is very similar to what you were working with or working on with your API. It's the same database structure. And essentially what has happened here is you can actually view things, you can edit things, you can delete things, you can create things. It's a very, very simple CRUD, website. So essentially this is going to be the website that you need to apply the design pattern on. So it's already in an architectural pattern, which is MVC. So we've got the views, we've got the controllers, we've got the models. And now what you'll be doing is you're going to be taking the logic that you have here in the controller, and you're going to be chucking it into domain logic and into the business logic layer, into the repository layer. So essentially this is very easy to spin up. Next week, I'm going to show you how to spin up a web app so that you understand how to spin it up. And then we'll actually go into how you can break this stuff up and what the different principles are when you're looking at solid. So for your project 3, in essence, what you're going to be expected to do is take these controllers and actually apply the design patterns to that. So you'll see here there are a few things that you can start looking at. There's a few things that we'll be giving marks for. And then once again, you'll need to host it. You'll need to make sure that there aren't any credentials, which at this point there aren't. If you clone it, you'll need to put a project, an app settings.json together. The app settings.json is pretty simple. The app settings.json, you can probably use the one that's in your API. Mine looks very simple. Don't stress too much. This is going to be something that you're going to be getting in any case. So if you've got this and you set up your app settings.json like this, you should be good to at least start testing and seeing if this works for you. You don't need to get started on it right away. If you want to play around and you want to understand how that works, it's completely up to you, completely okay with that. We've added some links in here that you can go through, some groups that you can go look at. There's a submission form over here. And these criteria, this marking consideration and submission criteria might change a little bit, which is why we just need to confirm this before we upload a new version. So that is the project 3 that we're looking at from this perspective. Just to kind of summarize, you're going to get existing code. It's a web app, so you'll just need to fork the repository. I've now showed you where to do that. Or showed you where to get it. Just please don't forget to add it as a reference to your project. Then the web app will be functional when you receive it. So it'll already be connected to the data source. All that you then need to do is apply principles, patterns, and best practice standards to existing code. You'll also be expected to host it on the cloud. So if your subscription has expired, we're still trying to figure out how we're going to work around that. But essentially, it should be fair that you forfeit the marks because of the costing aspect that you haven't paid attention to. So we're still going to figure out how that works and then give feedback, but that's our current stance on the matter. And then you'll get a rubric and we'll go through some useful information next week. So don't stress too much just yet. It's just to kind of show you what we're expecting so that if you want to play around, you can. If you don't get there just yet, that's completely okay. We will make it there next week. I think there'll be a little bit more clarity. It also just gives you a little bit more time to kind of work on your project 2 for this afternoon. But as soon as that's done, then you can start playing with this. Okay, then any questions? Let me just get back here. Okay, where do we get that link, ma'am? So that link is available in the project 2 brief and in the project 3 brief, although I haven't uploaded the new project 3 brief just yet. So what I can also do is just do this quick. Let me just get the correct repo link because that's a folder view. All right, so are there any questions about project 3 so far? Okay, cool. Then what I'm going to do is I'm going to stop this recording and we're going to